Hello and welcome everybody. Hi, David. And
Hi, how's it going, Alex?
it's good. It's good. How are you?
Doing pretty well. Did a lot of running over the weekend. I'm a little on the tired side, but I've had
Oh,
some coffee, so good to go.
that's good. That's good. We're missing Michael, but I'm sure he's on his way through the internet. Yeah, welcome everybody, and thank you for joining. This is Aura Office Hours, Aura DB. We should probably call it Aura DB/S Office Hours now, because there are now two Aura versions available. Where you can ask your questions on all kinds of things Aura. So if you have just started with AuraDB or on free or any other edition, mainly on free, I guess, and have some questions what to do next if you are stumped with something, this is your session. We I guess we take also AuraDS questions. So if there's anything coming in that regard, also uh, open up. There is a link. I'll post a link in chat one more time, which you can use to submit your question. So it's the best way to submit it via that. I mean, if you post it in chat now, we probably won't be missing it and we'll see it. But if you want to make 100% sure that we will not miss your question, type it in there, and we can then go one item after the other and go through it there, and that makes it probably the best way to go by today. Yeah, and then other than that, it's open, it's interactive, and we try to answer as many questions as we can, and we stop either if we run out of time or out of questions, depending on what comes first. Yeah, I see you have already prepared some slides. Let's go in there. I get the caption out of the
Yeah,
way.
so soon what I'm going to is I wanted to just spend a minute or two introducing myself and Michael, who's going to be joining us. Oh, there you go. Hi, Michael.
There
Hi,
he is.
Uh,
Hi, Michael.
yeah,
sorry.
your timing is impeccable. I was just about to tell people who Michael Hunger is, but you're going to do a better job of that than I am. Hey, Alex, real quickly, somebody on the chat actually asked us to activate the subtitle module, I believe. So if we don't have subtitles configured, if you could add that, that'd be great. Michael, do you
I
want to
think
start off?
because we are live, people, I'm actually not sure this. YouTube does this automatically. So if you are watching this live on YouTube, you can click that button and enables subtitles. It should be on, but I'm going to double check.
Thanks. Michael, do you want to start?
Yeah, sure. So sorry for being late. This was such a sunny and beautiful day outside, so I ventured for a walk and then I went too far and I didn't get back in time. So I'm Michael. I've been with Neo4j for 12 years now, having been there since the very, very early days, tiny startup. But I'm really excited to see everything expanding in so many directions, especially also the cloud services. And so from that perspective, I'm really excited to be here and help answering questions about anything. And Alex and I am also running the weekly Aura Discover Aura free live stream as well on Mondays. So if you haven't seen that yet, there's also a web page with the video sessions so far, and it's definitely worth looking at if you want to see some new data sets to explore Aura DB with. That's about me. How about you, David?
Well, my name is David Allen. I'm actually based in Richmond, Virginia, on the East Coast. Been with Neo4j for about 4 years now, a little bit more than that, 4.5, I guess. And I'm the senior director of developer relations. So my job usually consists of working with people in the community and working with people who are getting started with Aura and want to be successful with graphs, and then just trying to help them do that. So I'm happy to be here today. Alex, if you can put up that slide that we're sharing. So we're going to right now pivot over to beginning to answer some of the questions that were pre-submitted. We've got this QR code up on the screen as well as the URL. As we're going along, don't even worry about it. Just submit your question and we will go through them in the vote ordering over here on Slido. So here are some of our questions that we've got. The first one is, can someone please tell me the differences between a graph, a vector, and a relational database? What are the pros and cons of each? This is like one of my favorite questions of all time. It's one that I could do a whole hour on, and in fact, we have a presentation that's about that, but we're not going to do an hour on this today. Let me try a quick version, and then Michael, see if you want to add something.
Yep.
So when you think about all these different database types, they organize the information in memory completely differently. And so a relational database basically writes rows and columns sequentially in memory and on disk. And so regardless of how a database does that, we could say that the database has a, quote, natural index to the data. So for example, if you have written a whole bunch of rows sequentially in memory, then going from one row to the next, to the next, to the next is automatically going to be a fast operation because it's literally set up in memory to do that. With a graph database, the way that we set that up in memory is by a series of nodes, much like you would have rows, but then relationships, which are basically like pointers. You have a pointer to the from node and a pointer to the to node in memory. And so in the same way as a relational database has a natural index and gives you an natural advantage to go from one record to the next, graph databases are set up in memory to facilitate you traversing a lot of those relationships, because basically you're pointer chasing in memory. That's all traversing a graph really is at the bottom of it all. Now, what are the pros and cons of each? Well, it definitely depends on what you're doing. If you're in a relational database and you want to do a mass scan of 100 million records, let's say you've got 100 million customers in a database and you want to find all of them where their postal code is ABCDEF. Relational database is going to do really well on that query because you're basically scanning a large number of rows and then filtering them. Okay, so we would say that the primary the natural index of the database is well set up to do that kind of a query. On a graph database, for example, it's all about relationships and it's all about traversal. So if you had a query like, let's say we've got a human resources graph and we know who reports to who, and you say, well, how many people does Emil Eifram manage directly or indirectly up to 3 levels deep? In order to find the answer to that question, you're going to have to traverse a whole lot of boss direct report relationships. Because of the nature of the question is very relationship oriented, a graph database is going to do better for that one. So that's my attempt at a fast answer. But you want to add something, Michael?
Yeah, so it's really use case specific. So as you said, databases have one native data model usually. You can put other data models on top of that, but their native data model is how they structure data on disk and in memory, right? So that's what they are focused and built for, right? And then you can put other things on top. And Alex and I this morning actually had a good thing that we discussed is a good use case of graphs is also to kind of find insights from this between the lines information, right? So kind of the contextual information. What, for instance, if someone tells you, tell me who your friends are, and I tell you who you are, things like that, right? So things that are not obvious in the data, but more in the how things relate. So graphs are really good at these kind of things as well, right? And in general, I always said kind of graph databases, or most graph databases are like a next generation of relation databases because they keep some of the good stuff like transactions and ad hoc querying and a flexible data model that you can use really well with applications, but they add these extra features that you can't do easily with a relational database, like relationships as first-class citizen and not like as an afterthought with foreign key relationships and things like that. So from that perspective, I see them more as an evolution. We learned from the things that were good in relation databases, but we also saw some of the gaps. And in a graph database, you fill some of the gaps. Of course, as you said, David, things like data warehousing and massive number crunching of raw data is not something that graphs are built for. So that's something that it's not one of the main use cases that people use graph databases for.
Yeah, so there are pros and cons. There's good fits and there's bad fits. I posted as a follow-up to the question this particular article that was written by our colleagues Lou and Will called Will It Graph, Identifying Good Fits for Graph Databases, Part 2. This really kind of goes through a lot of some of these principles in depth. From my perspective, like the database field kind of fragmented a lot about 20 years ago now. And it used to be that relational was the only thing that was out there, and it broke out into all of these different use cases that Michael is talking about. So they're all good. It's not like you should use Neo4j for absolutely everything. They're all good. They all have areas of strengths and weaknesses, and this will go a lot deeper into what some of those are. I hope that addresses this question. I'm going to mark this as answered. If we didn't capture the intent of any of these questions that we're answering, put in a follow-up and we'll go back through it.
Yep.
So the next question, Michael, maybe you want to take this one. So the user is basically creating nodes and edges using Pi to Neo, and they want to know how they can be seen on the web through AuraDB and visualized.
Yeah, so that's actually pretty straightforward. Let me just share my screen really quick. One second.
Sure.
Yeah. So, and it may, so I just created an AuraDB free instance called AMA, because we are in the AMA here. It's currently empty, and there's a connection URL, which is important. And what's really nice there is, if you click on the database, there are connect examples. So for instance, here's the Python connect example. And so this one shows the code for the official Neo4j Python driver, not for Python Neo, but the Python Neo code is very similar, right? So you basically import your APIs from Python Neo from the library, and then you can create a connection to the graph database. And with this graph database, you can create data and read data as well. And what you do is you pass in this connection URL, the username, which is Neo4j by default for the default user, and the password that was shown when you create this database. So similar to how you do it here. So we can actually look at the Python Neo docs as well. Let me just do this 1 second. Come on. Browser is misbehaving. Yeah. Python Neo docs is Python Neo handbook. So you basically import graph, and then you basically connect to the graph like this. But instead of providing bold localhost, you provide the connection URL from your Neo4j AuraDB database. And then whatever you do with Python Neo shows up in your database. So whenever you go to your database, you should then see the nodes and relationships showing up here. And then you can click either here in the database tab to visualize them, or you can query them with Cypher directly in Neo4j browser, or again in Python Neo as well, right? So so I don't know if you want to show something running, but otherwise I can also pip install Python Neo really quickly and show something in the Python. But
if you
I
want
think
to,
it should be straightforward. Let's see. So we're just installing Python Neo, and then you can use Python 3 here. And then basically we just take Nigel's example code here, but instead of using bold localhost, we use our connection URL that we have here, and also here in our AuraDB. Copy this, and I just paste this in. Authentication is Neo4j, and password is whatever I got from back from Aura. Let me find this 1 second here. So this, boom, sorry, I forgot the import. So, and then we can just say graph.run, and then for instance, unwind range 1 to 100, SID, create person name is David plus ID and ID. And then that's about it, I think. And I have too many double quotes here. So, and this ran this operation. And then if I look here, I have my 100 people, which are currently not connected, but I could now go and connect them basically and see the data. So that's how you can go from Python Neo directly to your AuraDB instance to see the Neo4j browser. Or in
So
Bloom.
Michael, if you could up your screen size resolution a little bit, folks are having a little hard time reading your terminal. If you can crank that up a bit.
Yeah, I can make this bigger.
Yeah, there we go.
So this should be better. I can also make
Thanks, Dave, on the live stream for noting that.
Yeah. So that should be better to read, easier to read. All right, so we basically, what we did is we imported a graph from Python, then we connected to the database with connection URL, username and password, and then we ran a statement here. But whatever the Python APIs are that you use, they will basically show up in your AuraDB database, essentially. Cool. That's it.
Okay, so thank you for that question. Going back to our list, the next question is how to use created graph to query using AuraDS using Python with graph algorithms. So we've got a bunch of questions here today about AuraDS. And so that is the data science iteration of our Aura Cloud platform. Up until 2 or 3 weeks ago, the way that you would do this is that you would just use the vanilla Python driver that we have, very similar to what Michael was showing with Py2Neo, just using a different library. With GDS 2.0, though, there is now a wrapper library or client library for GDS called Graph Data Science. I'm going to share this link, and let's see if I can increase the screen size so folks can see this. So this is a Colab notebook with Google, where basically we can run these individual steps, and we want to install a module called Graph Data Science. And then this kind of code notebook view shows you exactly how to use it and connect to it. So the benefits of doing it this way is that you get a client library directly for Graph Data Science that is going to let you run all of the different algorithms that are involved in GDS as basically native Python functions rather than interacting with it at a cipher layer. So the way that you get started with this is that you just import the module right here. You specify your username and password that came from AuraDS. That gets given to you when you create the database initially. And then you create a client instantiation like this. You say it's AuraDS. You give it the username, URI, and password. Then when you want to call GDS functionality against your remote graph, you just basically use the GDS module and then you call functions directly on it. Like in this particular case, it's gds.version. So what this library doesn't necessarily load data in for you, although there are some functions available to do that through the driver. What this library does is it allows you to run all of the GDS functionality as basically native Python functions. So if you've already got that graph, let's see, in the question was, how do you use the created graph to query using AuraDS using Python with graph algorithms? Assuming you've already loaded data, this is the way that I would go with it. So this particular Python notebook, I'm going to copy it and put a reference into it into the question. But you can always get there through the official product documentation for AuraDS. So if you go to the Neo4j Aura documentation, connecting to AuraDS, connecting with Python, you'll see that this notebook that I'm talking about is linked directly in documentation. So I'm just going to put a reply on that with that and mark that question as answered. But basically, if you're new to this kind of approach, I would recommend starting with this Colab notebook and then stepping through it block by block. So you can, for example, list all of the things that you can do inside of GDS or work with schemas, all kinds of other things. There are a number of helper functions in here where you can generate example graphs, create graphs, them, etc. So when you start using this particular library, it's all the way back to working with GDS itself. So when you get into the official product docs, which are right here, you'll get into like all the different graph algorithms. And so let's say that we were interested in the PageRank algorithm. You'll see in this docs page that it's gds.pagerank.stream with arguments of graph name and configuration. In the Python wrapper library that I'm showing, it works the same way. So you would call a Python function called gds.pagerank.stream with all of the same configuration parameters. And bam, using GDS against AuraDS, native Python in a notebook. Hopefully that clears that up.
Yeah.
The next question, this would be a great one for you to take, Michael, is can we import tabular MySQL into Graph for Aura?
Yeah. So that's a really good question. So there are several ways of doing that. So one way of doing that that's pretty straightforward is exporting the data from MySQL to CSV. So basically you do export the tables or the select statements that you want to import as CSV to your, let me do this on my screen. Can I enable my screen? Yeah, super. So if you are in your Aura instance, like my AMA instance here, there's an import button, and this gives you basically an easy way of getting CSV data into Neo4j. So you could take the CSV from your MySQL export. So for instance, we have one in the Northwind dataset. There is, let me do this here. Underneath the graph examples, there are a number of example data sets from network management, recommendations, Stack Overflow, entity resolution, cybersecurity, and so on. So you name it. And one is Northwind and Northwind. And here we actually added in the data folder also the, in the, where's it? Into the import folder, I think I put it. There's this zip file here, which I can download. And replace. And which basically combines a data model with the CSVs, but also in the import folder here are the individual CSVs, and then you can manually manage that. And when I import here my model with data, then what I get is here a graph model. So you see it's a retail model. So we have order, products, categories, suppliers, shippers, customers, employees, and so on, and the CSV files for each of those. And so they were actually coming from, I think, MySQL or Postgres originally, as you can see from the naming. And then if you want to import this this data, then you would just click on Run Import. Here is your Aura database URL already filled in. Username, I just need to get my password. And if I do this and click on Run, then it goes ahead and imports this data, which should be pretty quick. And then if I go back to my Aura instance, I see now all our nodes from our Northwind data model imported. So that's one way of importing relational data. The other one is, of course, you can just use your programming language of choice to connect to the relational database and to Neo4j, and then basically pull the data from the relational database and send it to Neo4j as well. And the third one is using the ETL tool, which is a little bit more involved, but helps with more complex migrations. So if you go to the Neo4j developer side, then you see in, I think, here and get started, there's some data, there's a data import section. And in the data import section, there's an import RDB master graph that shows you how to import things via CSV, epoch, the ETL tool. I want to add the data importer, which is very new here to this as well. There's also Kettle or Apache Hop and other ETL tools like Talent and NiFi and others that are also possible and supported. But the Neo4j ETL tool basically allows you to connect to a relation database and to Neo4j, and then basically pulls the metadata from the relation database into the tool, which you then can inspect and modify, and then you basically say, yeah, I like this model, and import it directly from there. So the Neo4j ETL tool is currently available with Neo4j Desktop. So it's a little bit more involved to get it installed because it has some backend installation requirements. But in the future, I hope that the data importer tool actually will support other data formats and data sources as well, so that it becomes even easier to do this as such. So that was my quick overview over this topic. But
All right.
I'll paste this data import link and the other links into the chat as well for folks to follow.
So thanks for that question. Hope that covered it. There are a number of different options for how we can do that. This next question is a little bit tricky. I'm going to have to break it down because there's a couple of different ways this could be meant. So what's the easiest and best way to convert a field inside of AuraDS into a vector so that we can use it for graph data science similarity measures against it? So vector here might mean a couple of different things. So it's possible to have a property in Neo4j, which is an array, which is probably not what's meant. If the questioner here wants to follow up with a little bit more detail, hopefully we can get our answer a little bit more on point. Typically, when you're going to do a similarity measure, you're going to project nodes into a graph in memory. But there are a number of ways of doing that too, Michael.
Yep.
I'm trying to be helpful here, but I'm kind of guessing at what the questioner means here.
Yeah. So exactly. So the vector is basically an embedding vector, meaning an array of floating point values, right? So that's then used in machine learning. And there's, of course, as you said, many sources for that. So one source for a vector can be something like already you got embeddings from somewhere else. Another source can be that you take existing properties and add them together into a vector. For instance, you have something like an attribute like for a person, you have something like height and weight as two attributes, and then you have things like gender, where they live, and so on. And so you can kind of combine all these attributes into a vector. So you have like some floating point values, but then also something like gender or location can be added with a one-hot encoding to a vector. And there's also some helper methods in the graph data science library that allow this as well. So you get actually there's in the docs. Let me see. For instance, one-hot encoding and scaling properties are two. I'm just adding them to the chat as well. So you can, sorry, not split relationships, but scale properties. So you can rescale properties and do one-hot encodings. But the most likely thing that people will do is basically running node embedding algorithms. So you take a graph with a number of attributes and properties on your nodes, plus the topology. And by running one of these node embedding algorithms, you take both the topology as well as the attributes and turn them into embeddings or vectors as such. And here you can also say how large you want your embedding to be. So for instance, 128 or 1024 floating point numbers in your vector and the scale of your vector. And that's the embedding dimension, right, that you provide. And then the node embedding algorithm will create the embedding itself. But it could be any number of combinations of that, depending on how you want to, or where you want to take your data from that you want to run in your ML model as such. Right? So from manually constructing the vector to using helper functions like one-hot encoding or scaling to all the way to node embeddings. Or actually, you can also use language embeddings as well for those. Right. So by running NLP algorithms on top of the data in the graph, you can also add additional language embeddings, and then you can combine them all together into one larger vector and use those for the ML algorithms that you want to train, or ML models that you want to train as well. And for the ML models, actually, there's additional capabilities. There's a pipeline, the new pipeline feature. There's a model catalog as well, which can store trained models as well. And so there's a lot of stuff that you then can do even in Graph, in Neo4j, running your ML pipelines directly inside of Neo4j as well. But you can also integrate with external sources, like there was a really good blog post with, let's find this, Vertex Neo4j. I think Ben, our colleague, created a nice example. Yep. I also put this into the chat of how to combine graph data science with cloud machine learning pipelines as well.
So thank you for that question. If we could go back to the question view real quick, Alex. So the next question, I think it's from the same person, has to do with how you best compare and change the results of community detection algorithms on a large graph, i.e. avoid monster communities. So I've got up here the documentation for just one of the community detection algorithms. This is label propagation. Now, the way I usually think about community detection is there are different kind of levels of fuzz where at one setting, your entire graph, regardless of the relationships, is a single community. And at the opposite extreme, basically every single node is a community of one. I don't know that there's a general answer to how you prevent this because it depends very much on which algorithm that you're using and how you tune the hyperparameters. But here's what I'd tell you to do is go into these community detection algorithms that you see here on the left-hand side, and then check out their configuration. So you'll see that there's general configuration based on a name graph, and that's the same for all of them. And then there's algorithm specific configuration. Like, for example, with label propagation, you would play with max iterations in order, as well as possibly the node weight property to control the number of iterations that you're going through and the number of communities that you're likely to end up with. If you were using, on the other hand, the weakly connected components algorithm, that has a different set of parameters, and the way that you would tune this would be different. Now, I'm a software engineer. I'm not a data scientist by trade. And so at the end of the day, when you want to get really fine-grained control over these algorithms, there's no substitute for understanding how it works and what the math is doing underneath of the scenes. That in turn can give you like a really more principled view of how would you tweak this hyperparameter to get bigger or smaller communities. So I hope this answer kind of helps. Basically, my advice would be focus in on which community detection algorithm you're using. Make sure you understand why that's the right one for your use case. Check out the hyperparameters. They're always going to be found here in the algorithm specific configuration, and tweak those to get to your happy place.
Yeah. So
basically,
what you how you can see community detection clustering algorithms is a community is nodes that are stronger connected with each other than with other nodes of the graph, right? So, and if you visualize such a graph, then you can also imagine, okay, but there are relationships to other parts of the graph. But what happens, for instance, if we add or use a weight parameter? So, for instance, there's a relationship weight property, right? If you use a weight property on these relationships, then we could make other relationships magically disappear from our graph by kind of scaling the weight correctly, and these clusters would visually form basically already in front of your eye. And so that's one thing that you can really use is to say, okay, is there a weight on those relationships that I could either introduce or add that basically helps me substructure our graph, and that makes certain relationships virtually go away by having such a low weight that they are not being considered for kind of holding communities together. And that's
that actually ties
direct. Exactly what you said, basically, David.
Yeah. The threshold. So on this particular algorithm, it has a threshold. So if you make all of your edges weighted and then you set a threshold, it's exactly like Michael is saying. It's like the relationship is there, but it's not there enough to count towards the community computation.
Exactly, right. And one thing in Louvain, for instance, that's interesting, Louvain can also return the intermediate communities because it has also an iterative approach. It allows you to also return the intermediate communities, not just the final ones, but also the intermediate ones. So you can also control when do you want to stop, right? So because if you go too far, the communities get too small as well. But it allows you to play around with the iterations and the intermediate communities. And you might not want to go too far in the splitting of hairs or splitting of graphs as such, and then just reducing the iteration count helps there to get better community as such. But on the other hand, something you also need to say is you also need to look at your graph and say, okay, does it actually make sense for my graph naturally that there's more than one community also, right? So for instance, if you have a graph of a tight social network where everyone is actually connected to everyone, then it doesn't make sense because you won't get any fine-grained clusters from the just connection information. Then you need to add other attributes, like for instance, interests or other things as well, that then actually provide the clustered graph, right? So where your friendship graph might not be clustered, but if you add something like hobbies or interests or locations or whatever other second degree information. Then you get additional, like a layer on top of your main graph that kind of provides a new way of structuring the data that then causes communities to appear. Actually, Tomasz had a really good, let me find this. Tomasz had a really good article on that where he used a survey data set to cluster nodes. I think this one was it. Yeah, I just put it into the link as well. So there was actually quite a lot of information. I think 150 questions. So you had like the person-to-person graph, but then you had 150 dimensions that you could look at how are people connected, and then depending on which and how many you pull into your clustering information, this allows you to then see what kind of clusters do I find and how small or how big they are, right? So for instance, you had then at the end of his article, he found there are really like demographic clusters like young women or like older couples or things like that, the Netflix categories, which are really fine grained. So if you have enough dimensions in your source data, then your clusters can also be fine grained and very specific. So you could use them then also to very accurately describe this group of people or things that you want to identify as such, which I found really interesting. So this was a really good article from that perspective as well.
So just as a quick follow-up, there's a comment in the chat that says it'd be nice if there was some sort of function that looked at your graph and gave you some hints. I think he's referring to the hyperparameter tuning. So internal to Neo4j, some folks have been playing with a tool called Optuna that does that kind of hyperparameter tuning. I don't know if that's ready or not yet. But Optuna is a tool that can be used together. It's OP, there you go. That can be used together with some of this hyperparameter tuning to kind of cite examples. I've used a lot of community detection myself, and it was basically trial and error. But my understanding is that machine learning folks who are doing this on a daily basis, and I'll be honest, that's not me, are using tools like Optuna to do this.
Yeah.
So we have a couple more questions here. So the next one is, can you export very large graphs from AuraDS to local Neo4j enterprise installs? And I believe the answer to that one is yes. So inside of AuraDS, they do regular backups of your data, and there is an option inside of AuraDS to download a dump file. And those dump files can be used with Neo4j admin import from the dump file to an on-prem install.
Exactly. So you can basically, AuraDS has the same UI here as AuraDB, and you have this snapshot functionality where you can take snapshots, which result into a dump file, and then you can use Neo4j admin load to load these dump files.
That's right.
Either into your local installation, but also into AuraDB or AuraDS instances as well. And the other thing that's also possible is that from AuraDS, you can also clone directly into an AuraDB instance, for instance, or into another AuraDS instance as well, which is quite nice and useful. So for instance, if you want to take your a snapshot of your graph algorithms that have been running and want to put it into a more production like setup with AuraDB, where you have a transactional application running, then you can add this as an AuraDB instance as well, or as a local or self-hosted instance otherwise.
Yeah, so in general, those kinds of dump files are a good way of moving data back and forth between the two environments. So you're always going to be able to do that. It's a way of just picking up an entire graph and lifting and shifting it between whichever environment that you want. So I think with AuraDS, you need to schedule a snapshot. Those are not automatically done. Is that correct, Michael?
Yeah, you have to basically explicitly, because if you run algorithms and process, you don't want that to be interrupted by the snapshot taking. So that's why it's basically you say when you want to have the snapshot and not the system doesn't say that. So you want to be ready for all the data be in the snapshot that you want, and then you can do this. I can create an AuraDS instance. Let me do this very quickly in the background so that you can look at it later if you want to see the UI.
So some of our customers use this in both directions, right? So the question is about exporting AuraDS to local Neo4j enterprise installs. But a lot of our customers are kind of going through these migrations where they're starting to use AuraDS for the first time, or they're using AuraDB Enterprise for the first time. And this is how they're getting some of their data to the cloud in the first place, is creating these dump files, dropping them into the Aura interface, bam, new instance on the basis of that.
Yeah, exactly. Oh, here, this is the UI already. So if you can see this, so you can either pause your database. So if you don't use it, then that also is using less. And then there's this, clone to new and clone to existing. So you can basically take your database and clone it to an AuraDB or AuraDS instance as well. Besides taking the snapshots that I just showed you in AuraDB, you can also take these, take the database itself and clone it to an existing or new database as well. So you can also take snapshots that are not just dump files, but are already running live AuraDB or AuraDS instances as well.
All right. So we've got two questions remaining. The first is there any way for AuraDS to tell us what indexes it recommends that we create? Unfortunately, I think that this one is a no right now. There isn't an option for readily doing that. I think the deeper answer is what indexes you want to create very much depends on your query pattern. So there are some databases out there that have what you might call self-driving capabilities. And the idea is that the database would look at a query workload and it would see what kinds of questions you're asking of the database. Indexes are there at the end of the day to speed up access to the data for the most commonly used query paths. So indexes cost, and of course the database has to maintain an index. So you don't want lots of extra indexes that you don't really need and that aren't speeding things up for you, because you have the cost of maintenance without the benefit of faster access. So what indexes you can have, or what indexes you should have, is ultimately always dependent on what your query workload pattern is. I think it would be a fantastic feature to have in a future version of Neo4j, to have it look at your query workload and then suggest that to you. But that's not something that we've got in the box right now.
Yeah, exactly. Yeah, so there's some indexes that are automatically created. For instance, if you use the data importer tool, it will use indexes and constraints for your primary keys, but not yet for additional fields. So for instance, if you have like a location field or a datetime field or something like that, those indexes you still have to create yourself as such. And
so
but
like
that would be something that's really depends, as you said, David, on what fields do you want to query, because there might be a lot of data that you never kind of query, meaning compare with some other data to filter or to select, that you just store and return, then you don't need an index, right? So there's some databases that create indexes for everything from the get-go, but that's a big waste of resources as well. Because you need to maintain them, right, as well.
Well, and also, like, every time you write something new to the database, it has to maintain those indexes. So if you massively over-index, then it's sort of like creating a write penalty for the database.
Exactly. And
Michael raised the interesting example of the data importer. So the way the data importer works is that you often specify what the key for a node is. And then when you're writing relationships, it matches the A node and the B node, and then it connects them together by those IDs. And so that's a case that kind of proves the rule that we're talking about, where the data importer needs keys on nodes and then needs to be able to look things up by that key. And so it would create an index on the key for that fast lookup. Indexes are always paired with a lookup option or a need to use that in a query context. I hope that answers the question.
But what you can probably show, David, is if you do a query on data and we use profile, for instance, then we see actually.
Oh yeah.
For instance, here I have products in my database for my import, right? So and I have stuff like unit price or units in stock or so, right? So if I do a search from of products where n dot unit price is greater than, let's say, 20 or something like that, right? So then return counts down. Then I get 37 parts back. So if I prefix this with profile, I can actually see the query plan here, and it says that's the node label scan, and it does a filter. So it finds all nodes first with this label product, and then it runs a filter on all the nodes it finds where it compares the unit price with the value, right? But if I create an index on product unit price and rerun this query, then I see the index was created and it's online now. Then I see instead of fetching all nodes and then post filtering, it actually uses a B-tree index lookup immediately for the unit price. And the nice thing is that it also can then use something like automatic aggregation and so on. So for instance, if I return not the count, but for instance, the max of n dot unit price, then it will just fetch one element from the index and then use this automatically because it came from the index. It knows that what is the sorted max value, min value. And so it has 3 total DB hits only, right? So it's basically not touching the database at all, except for this one index lookup, right? And
hey, thanks for your comments, Tony TV. Tony TV is really digging this, Michael. You're on a roll.
Yeah, so profile is super helpful to identify what is the query doing under the hood, and that I also identifies. So, for instance, if I had some crazy number of nodes of some kind, so for instance, if I don't know, if I create or I don't have, how much do I have left? Like 45,000 nodes or something like that. Create person ID, age is ID modulo 100, and name is again David plus ID. Then I have these create. I have these 45,000 nodes, people nodes, and David 1 to 45,000. And if I now want to filter them by age, right? So n dot age is greater than 50 or something like that. And I put a profile in front of that. So here it's more visible, right? So because it needs to find, didn't I call this person? That's weird. There should be many more people than 177 as such. What do I do?
Maybe there's a slight typo in the label. So fun little thing about computer science here for folks who aren't familiar, like disk IO is really slow. I mean, we build good fast disks in the modern era, but disks are still really slow. And a lot of times what database indexes are trying to do is they're trying to get around having to read too much data off disk because that takes a long time because disks are slow. So basically what this index is doing is telling the database how to look up the right records so that it can just jump to the right spot and only load the data that is necessary rather than loading millions of records off of disk, which would be slow, and then filtering through them manually.
Right, so it had so few DB hits, by the way, because I returned only the first 25 rows and instead of all of them, and now you see it actually fetches 45,000. And if I now create this index on person age, then rerun this, then you see that it does an index and then it's much less data. It only fetches half the data as such.
Yep.
And you see also that the DB hits are much reduced.
So we're just doing this on simple test volumes that Michael is creating like on the fly. When you get into a real serious database and you've got billions or more of nodes, and you start running these queries with indexes, it can be the difference between a minute and a day in terms of how much runtime it takes the query to do. And indexes are they're just like the old school card catalogs at a library. If anybody remembers card catalogs at a library, it just tells you where to go to look. Imagine what a library would be like if you couldn't look up a book in the index and you instead had to exhaustively search every single shelf in the library in order to find the book that you wanted. All right, that's literally what indexes in a database are doing at the end of the day.
Yeah. And usually people sometimes think that graph databases or indexes are using indexes to traverse the data, but that's not true. So the indexes are really just used for finding the starting points in your query, right? So they are not there for kind of traversing the graph. That's kind of the pointer chasing that we talked about in the beginning. But indexes are really just for finding the starting points where to start from, right? And that's what you would do. Or for taking currently disconnected nodes, finding the pair, and then connecting it for the first time. And after that, you only follow the relationships as such. Cool.
Yeah. So thank you. Thank you for that question. A little deep dive on indexes. So this next one is kind of more of a comment, as I think that everything we consider can be modeled in graphs. It just depends on who abstracts to model of the logic of the interactions and their meaning. So this is definitely true. I've worked with a lot of databases in my career, and there was always this thing that we called the top dog problem. Okay, so you got relational, you got graph, you got key value. The question is, who's top dog? Okay. And all of these databases would go out there and, like, if you were an Oracle person, for example, they would look at all the data problems and say, everything can be modeled as a set of tables or relations in Oracle. True. So then you've got your Neo4j guys out there who are saying, well, the world is a graph. Everything is a graph. You can model anything as a graph. Also true. Key value store, well, it turns out that you can model everything in the universe as a key value pair if you wanted to, right? So the resolution here is that there isn't really a top dog. There's no one grand unified data formalism to rule them all. Rather, they're sort of like programming languages. They're Turing complete, if you will, and they can all represent everything. So I think the interesting thing is not whether or not a model could represent something, but what the use case is and how the model interplays with what you're trying to accomplish. So there are going to be cases where it's going to be a clear win to model something as a graph, and there are going to be cases where it's probably better to model things as a set of tables and a set of records. We touched on that in an earlier question about the pros and cons of each database. So it does depend on how you abstract the logic. And it depends on what kind of meaning you're trying to extract out of the data. There are some things where translating it into a different formalism like relational is just going to make your life harder. So there just isn't one to rule them all. That's just my personal opinion. If you're in a graphy space, you're typically going to benefit by using a graph database. That's not David Allen saying that you should use a graph database for everything. You know, that's kind of golden hammer thinking that we want to get past as engineers.
Yeah.
You have anything you want to add on that, Michael?
Yeah, so it's basically an what's the return of investment, right? So basically, is the graph database or the graph model adding so much benefit and value to my application that the investment that I have to do for instance, looking to a graph database with CTC or whatever, and then using the graph database to get benefits, is this something that makes a difference for me or it's significantly better than before, then I would make this step. But if it's only like a 1% or 5% improvement, then I probably wouldn't bother as such, right? So from that perspective, definitely has to provide value. What's actually quite nice about graph databases is that oftentimes you have a certain starting point, but then you discover more and more things that you can do suddenly that you couldn't do before. And that's kind of you first taking your first small step into the unknown, and then suddenly everything is possible, and kind of you see more and more opportunities as you go, right? So sometimes also a small change in the application, adding the graph, might be something that might not add all the value up front, but it opens up new possibilities of looking at your data differently and then getting new insights, which I found always quite interesting for me.
Yeah, that's definitely true about opening up new possibilities. If you think about a problem in terms of graph, you might spot interesting questions to ask that you wouldn't have spotted if you looked at your data another way. So definitely something to consider there.
By the
Alex,
way,
it looks like
one thing that I want to mention. So for those of you that can make it to Graph Connect, so we'll be there also in person. So if you have questions like this or know people that have questions like this, send them to Graph Connect. There's a lot of opportunity for in-person discussions and Q&A, and there's also something like a Graph Clinic or Graph Garage, whatever we call it this year, where people can answer. Also, like our field engineering team can answer really deep questions as well. So, so if you're into getting information from these kind of AMAs, then that's a really good opportunity to meet us, but also get all your questions answered.
Michael and I are going to both be there at Graph Connect. It would be really great to see some people there, and we're just going to be wandering around the halls at various points in time. So
need to get some AMH.
Please just like stop us, say hello, get some swag. I mean, whatever. We're there to have a good time. So
Exactly.
it looks like we've just got we got time for one more question. We got 4 minutes to go, Michael. The last question is there a size in terms of number of nodes and relationships at which refactoring a graph in AuraDB becomes problematic? Do you want to take that?
Yeah, so in general, when you want to refactor your graph, you need to have enough capacity, both in compute as well as memory and disk, to do the refactoring step. So you basically have the source data and the target data, and while the refactoring happens, you need to basically be able to keep this information as such. And as you can do this transactionally in smaller chunks, that's something that you can basically also do incrementally, right? So one portion of the graph at a time. So Neo4j 4, I think, or 4.3 added a new capability called colon transactions, which allows you to do operations and refactorings of the graph in smaller chunks. So you say, for instance, take this property of my nodes. Let's say we have a city property of where people live or something like that, right? So take the city property, turn it into a city node, and connect the person to the city where they live, right? So, and you have a graph of, let's say, 5 million people or something like that. And then you can do find a person and then do a colon transaction of 5,000 or 50,000 nodes. Do this extract city node and connect person to city node as such. And then it kind of goes off and will do this. It will take a few minutes perhaps to do the refactoring, but because these are small chunks, it's kind of an incremental change throughout your data. And something else that you can do in Aura as well, which is really nice compared to kind of self-hosted operations, is you can also scale up your database during the refactoring and then scale it down again. So it's not fully elastic as such, but it's elastic enough that you can say, okay, for this refactoring, I need perhaps for an hour or so double the size in terms of memory and CPU compute. Then I do it for the resizing of my database for this refactoring. And then afterwards, because then the data shrinks again of my data, of my graph, because I can remove the stuff that I don't need anymore. Then I can resize it down again as well, which is quite nice as a capability of a managed service as well, that I can scale this to my needs. Yep.
Well said. I think that about covers it.
Yep. Cool.
So,
thank you so much.
Yeah, thanks for all the awesome questions today. A lot of people have been interested today in AuraDS. So if you don't know what AuraDS is, take a look at our website and check that out. It's like the newest offering that Neo4j just launched about a week ago now. So it's basically a managed cloud offering for doing your data science work with GDS. So thanks.
Yeah. So there was also a blog post last week that we can share this. Here we go.
Yeah. Okay, cool.
Super.
Well, with that, I think we can wrap it up for today. Thank you, David and Michael, for taking the time and answering all these questions. Thank you, everybody, obviously, for asking your questions. I mean, this format lives and breathes by your your questions and your interactivity. So this is great
really
to see it work. Shout out to Tony for being so cool on chat today. That was amazing.
Tony.
Yeah, it's always good to see
and Dave
get the
as
feedback.
well. Thanks a lot for all the interactions and questions. Definitely very great.
Yeah, and thanks to Isaac too. So we're gonna continue to do this. You're gonna see Neo4j pop up to do this at least monthly, possibly more often in the future. In the meantime, if you have a question for us, definitely check out the Discord that's already in the chat, and you don't need to wait for the next one because there's always a bunch of friendly graph folks hanging out wanting to talk these things.
Absolutely. Yes. That's a perfect segue. Yeah, community is always open, and if you can't wait for this session to appear next, go and get in touch with our community on Discord, as David said, the community forums, Twitter, wherever. You'll find somebody that can help you, most likely on all kinds of questions.
By the way,
And
I just remembered something. If you go to Aura console today, there's also a direct link to the community and to Graph Academy now in the Get Help menu, which is really great. So if you go to your Aura UI, then in the Get Help menu you can find community directly linked in Graph Academy as well. So it's even easier to get there directly from inside of Aura DB and DS as well. So you don't need to find the link; it's already there for you.
yeah. And Isaac, yes, live chat is enabled, so should be available afterwards. But I'll always put the most interesting links. I hope maybe I didn't do this last time, but I put them in the description, so you'll find them there as well. Yeah, with that, thank you all for watching. Have a good rest of your day, evening, morning, wherever you watch this. Thank you again, David and Michael, for taking the time. We'll be back with this probably next month. And yeah, other than that, thank you all for watching and see you soon. Bye-bye.
Take care,
Bye-bye.
everyone.